Okay, so we're going to finish 1.9. We had one little thing left to do, and then we're going to start chapter 2. Okay, so 1.9, what we did so far last class was inequalities with the quadratic. And you just move everything to one side and factor, use quadratic equation. 2, the second type is absolute values with the quadratic. You set it equal to plus the number minus the number and solve your two equations. And then this is where they're mixed. So what was the rules when they're mixed? So if we have some absolute value of something is less than a number, then we're talking about this region in between two numbers. And you write this as now to solve it, we break it up into two different parts and solve each of them. But usually our answer is in between. So that's type 1. And type 2 is if we had a greater than sign. So greater than means farther away than A. So it would be x is less than negative A, or x is greater than A, or because they don't overlap. Oh, and is when you overlap, this is and, or is when they go in different directions. Okay, so that's really important, and as evident on the test, you didn't quite remember that, most of you, so you should have that memorized. That's a thing. And you see it a lot in calculus, so if you memorize it now, it'll make it easier when you see this in calculus and say, oh yeah, I know what that is. Okay, so here, this is type 2, greater than. So greater than 6 means that it's on this side and this side of 6. So that's type 2, greater than. If you draw the number line, you might remember better. Instead of x, we have x squared minus 3. Yep. No. Well, we do in the next step when you're solving it, but we'll do an example like that in a minute. Okay. The question was, do we need to put and in type 1? And the answer is not when you first set it up, no. And your final answer, no. But when you solve it, you could put and or not, but and is what it is. So this one is or because they go in different directions. So if that had been, this would be the answer. But it's not just an x in the bracket, it's an x squared minus 3. So instead of saying x is less than or equal to negative 6, we say x squared minus 3 is less than or equal to negative 6. That's this side. And instead of saying x is greater than 6, we say x squared minus 3 is greater than or equal to 6. So it's the same process, but we're going to get a new number line with different numbers. They're not going to be 6 once we solve it. But that would be how you set it up. Okay, so to solve each of these separately, so the first one, x squared minus 3, we change it to an equal sign to solve, bring everything to one side. What's the solution to this? When it's an x squared and a number, it's either minus and its difference of squares, or it's plus and it's, right, no solution. So there's no answers here, no solution. I mean, just look at this, x squared. What does the square do to a number? Like it multiplies by itself? So if I put like a 1 in here, 1 squared is 1 plus 3. Is that equal to 0? No. If I put a 0 in here, do I get 0? No, I get positive 3. If I put a negative number in here, do I get 0? it's always going to be positive because we're squaring it, and if you square a negative or a positive number, you get a positive answer. And then we're adding another 3, so it's always going to be positive, no matter what we put in here. It can't be 0 or a negative number, so there's no solution. So the second one, again, change the sign to an equal sign. Move everything to one side. This one's a difference of squares. Because of the minus sign. Plus 3 minus 3. So x equals 3 or x equals minus 3. Now, we have to test it with these ones. So we want to just double check. Because we don't have the equality anymore, usually it'll be on the outside, but sometimes it'll be in between, depending on what the actual question was. I'm going to show you one that's out on the two sides and then one in between. So I'll show you both cases, but just like the ones we did last class, an inequality and a quadratic in the same question, you have to change it to an equal sign and then test it on a number line. So how do we test this on a number line? What did we do? Pick a number less than -3. Let's go -10. Between -3 and 3, 1, 0. And bigger than 3, 10. What do we test those in? The original. And we're seeing if it works or doesn't work, a check mark or an X. So if we plug -10 in, we get -10 squared is 100. 100 minus 3, so that's 97. Absolute value of 97 is 97. Is that bigger than 6? Yeah. So that worked. If we plug 0 in, 0 squared minus 3, minus 3. Absolute value of -3 is 3. Is 3 bigger than 6? No. And will the 10 work? So this was plugging in the -10, plugging in the 0, and plugging in the 10. So that works. So now we figured out what works. How do we write our solution? This is x is less than -3. And then it skips a part, and then it's x is greater than 3. What do we put in between those? Or, because you can't be in both at the same time. That would mean and. You're both less than -3 and bigger than 3. You can't be. So it has to be in here or in here. The answer is here will work, or any answer from here will work. So that would be your solution. And if you had to draw it on a number line, that would be. Okay, so I said you have to test because sometimes, unlike the linear equation ones that we did before, unlike that, sometimes your answer will be in the middle. Okay, so let's do a second example. Oh, shoot. Just don't write that. That was not the example I wanted. Just a sec. Okay. Okay, so what do? first thing you say to yourself is, this is a question with an absolute value and an inequality. I need to rewrite it. I always just go off to the side and say, okay, this would be minus 5 and 5. Which way do I want to go? Greater. So that would be bigger and bigger. And they'll be colored in. So I just look at this part first. And that's to decide what to do. So then I said, okay, well, these are the two regions that we're starting with. So we say that, and remember, this one would be less than negative 5, and this would be greater than positive 5. So we take, instead of writing x, we write whatever's in that bracket. So 9 minus x squared less than negative 5. And the other one is 9 minus x squared greater than 5. So those are our two equations. To remember them, unless you're really good at memorizing, you probably have to draw this and then write them out and then copy them down with the right, sort of the right argument is what we call it, whatever's in the bracket. Okay, so now we're going to solve these two. But to solve them, you have to change it to an equal sign. So the first one, 9 minus x squared equals negative 5. So how do we solve that? So remember, when there's a negative in front of the x squared, what do? We take out a negative 1 or move them to the side. We always want the x squared part to be positive. That makes things easier. So let's move them all over to this side. So we have 0 equals, minus 5 was already over here, plus x squared minus 9. So what's that, 14? There it is. Can this be solved? Yeah, it's a difference of squares. It's not a nice difference of squares, but it's still a difference of squares. What do we do when the number doesn't have a perfect square root? You just write the square root. So it's a difference of squares because it has a minus. So x plus root 14, x minus root 14. So x equals minus root 14, or x is plus root 14. So there's our two answers from that side. Before we do the number line, we have to see if there's more, because there could be 4 possible answers that we need to put on the number line. Usually one of the two doesn't work, but not always, okay? That's not a rule that only 2 will work and the other 2 won't. So there could be up to 4. Same thing here. Change it to an equal sign. Let's bring everything to the right this time because we want that positive x squared. And what type is this? Also difference of squares. So x equals minus 2 or x equals 2. So we've got 4 numbers to put on the number line, but we have to guess what root 14 is close to. How do we do that? Yeah, think about the roots you know that are close to it. What root do we know that's close to that? 9 and, yeah, square root of 9 is 3. Square root of 16 is 4, and square root of 14 would be in there. And I said, I was doing this actually last night with a friend of mine's daughter. She's in grade 11, so they were estimating these in grade 11, but they had to get them right up to 2 decimal points. So you take a guess, then you would square it and see if it works. Then you would go closer, right? If it was a little too big, you'd go a little bit smaller. So we had to, here, no. Just get it, even if you put 3.5, it'll work, because you're just trying to get it on the number line between the right numbers. Which one is it closer to? Oh, what's that symbol? 14 is closer to the 4 than it is to the 3, so let's say 3.8. Okay? It doesn't matter. But like I said, if you wanted to actually check this, you could multiply 3.8 times 3.8 and see if you get 14. You could do it out long, but we're going to just... So I get 14.4. What would that mean if I was trying to be more accurate? Go a little smaller. So if I tried 3.7, too small. So 3.7 was too small, 3.8 is too big. Yeah, 3.75. 14.0, really close, right? Do you see it? So that's what you would do, and that's what we were trying to get closer and closer so that she had two decimals that worked close, which is that would be the answer for that one. Okay, so 3.8 is a good guess. So we have, do I write equals 3.8 up here? No. I do a little squiggle. Because it is, that's your guess. It's not exactly right. So we need 2s and 3s on here. So 1, 2, 3, 4, negative 1, 2, 3, 4. So root 14 is like negative 3.8. 1, 2, 3, so around here. And am I going to write 3.8 here? No, I'm actually going to write the right answer because we're just using that as our guess. And then positive 3.8, 1, 2, 3. And then negative 2 and positive 2. All right. So it's important to get the unknown ones sort of in between the right two numbers anyway, because when you have to test a point, you have to make sure it is, in fact, in between those numbers. So we want to test this region. What would be a good test point for that? 0. Now here, remember this is like 3.8. So what's between 2 and 3.8? 3. Bigger than 3.8? 4 if you want, or 10. I always go in like that, 10. Between here would be negative 3, and down here would be negative 10. This is a huge part of calculus, doing these number lines and putting your test points and testing it out. Like for weeks, you have questions that you have to do this stuff for. So what's important is to know that usually all the numbers don't work out nice. Usually there's a few that are roots that don't work out, so it's good to be able to estimate them, to get them on the right place. And then you have to be able to plug numbers in really accurately, even if the question is kind of yucky, which it sometimes is. So we're going to plug each of these in. What are we plugging them into? Always original. 9 minus x squared. And what we want is the answer to be bigger than 5. So we're going to put negative 10 in here. 9 minus 100 is negative 91, which is 91. Is that bigger than 5? Be careful because you're doing absolute value. You don't want to look at the negative 91. You want to look at the absolute value of that, which is positive 91. This is greater than 5. So this region works. So before the negative 14 works. If you just put little dotted lines, I often do that if I'm teaching calculus, so you can see the divide. Because when you go to draw a graph like this, you draw this part, this part, this part, this part, and this part all separate and join them together. That's what you're going to learn how to do in calculus. Negative 3 is the next one. So 9 minus a negative 3 squared. 9 minus 9. What? Okay. Sometimes it takes me a minute to think. 0, okay. Is 0 bigger than 5? No. That would have been a point where a student would have said, 0, that doesn't make sense, I did something wrong, and then just quit. Don't do that. So what I'll tell you what I was thinking is that I was thinking because we were setting it equal to 0, but there's a 5 there, not a 0. Like usually when you factor something, you're setting it equal to 0 before you factor. And if that were a 0 here, that would have actually been one of the numbers that we weren't testing. So I was thinking, should the 2 be a 3? Like, did I multiply something wrong? But then I realized we're looking at 5, not 0. So it's all good. 0, 9 minus 0, 9, greater than 5? Yes. And what do you think's going to happen here? Yeah, are they going to be the same? Just look, if we squared a 3, is it going to end up with the same answer as squaring a negative 3? Yeah. And if we square a positive 10, is it going to be the same answer? And it's useful to do that because if you need to plug in a whole bunch, if there's like 7 numbers to plug in, but half of them are the same as the other half, it's less work. So what's going to happen here, if we plug in a positive 3, it's going to give us 0, and that's not going to work. And if we plug in a 10, that's going to give us 9, and that is going to work. So no, yes. So where is our solution? 3 places. So we write the first one down, or the second one, or the third one. So what's the first? So x is less than, was there an equal sign in the original question? You can't see it there, but yes, there was. So we put an equal sign. Less than or equal to negative root 14. You write comma. The next one is between negative 2 and 2. Negative 2 and 2. And the last one, x is greater than or equal to positive root 14. So we did 2 questions. Now the first one only had this answer like that. Where was the 4 points? Why didn't this one have 4 points? Right, this part didn't work. When we solved the 2, we didn't get answers for both. What if you got no solution, no solution? Right, nothing else to do. Or is there? It doesn't mean no solution overall. I'll show you why. Yeah. If you put 10, you get 9 minus 100 is 90. Oh, yeah. Yeah, I was looking at the wrong one. Yeah, there. Yeah. Okay. Okay. So let's do one that's, oh, why did I say 5? Because there's 5 on my list, but I already did some of them in the other class. So 3. Okay, so let's do one that's less than. So instead of greater than, it's less than. So when you put, so you say 5, negative 5 and 5, where would that be on here? Less than 5 from 0 is these numbers. They're less than 5 away from 0. I put an equal sign again, so we'll color them in. So to set this up, you would write the smaller number, like that. However, it's not just an x, it's this x squared minus 4. So you need to put that in between 5 and minus 5. So we would say minus 5 and then we split this up to 2 questions. Sometimes we'll be able to put it back together at the end, depending on what the answers are on the number line. But again, with these ones, you're testing the regions, so you'll know exactly which ones they are. So it doesn't matter so much. So we take this, minus 5 less than or equal to x squared minus 4x. And then we do the same thing with the middle. And split it up to 2 questions. So that's how that works. So this one. So the middle goes with the minus 5, and the middle goes with the positive 5. Now to solve these, we change sign to an equal sign and see if we get numbers that work. So minus 5 equals x squared minus 4x. Bring everything to one side. Are we going to bring it to the left or the right? To the right, so that the x squared is positive. X squared minus 4x plus 5. Does this factor? I don't think so. So if it doesn't factor, or you can't figure out the factoring, you might do it wrong, and then that'll just mess everything up. But this one doesn't factor, because you would do 5 and 1. And if you subtract them, it gives a negative 4. But if one of them is negative, because you have to subtract them, then it gives a negative 5 at the end. Yeah. Remember, if it's a plus at the end, it's either both positive or both negative. So this doesn't factor, so we could try the quadratic equation. And it either is going to give us 2 numbers that we're going to have to estimate where they are on the number line, or it's just not going to work. And it won't contribute to the question. So, minus b, that's a minus minus 4. B squared minus 4 squared, 16, minus 4 times a times c. Does it work or not work? Do we get a negative under the square root? Yeah, so no solution. That's because there's a negative under the square root. So that didn't contribute anything to our number line. And this one's either going to give us 2 numbers or it won't. So our second one, x squared minus 4x equals 5. Bring it all over to one side. And this one does factor. So x minus 5, x plus 1. And then what do we do with those? Right, put them on a number line and test. We don't have as much to test because there was only 2 numbers instead of 4. So a number in between, maybe 0. Number bigger, 6, 10, 100, whatever. Smaller, negative 2. You could do negative 10. Would probably be a good choice in case they look the same when you plug them in, but we don't have to. Could be any number smaller. Okay. And what do we plug those into? The original. So the original was x squared minus 4x. So 4 plus 8 is 12. And what do we want it to be? Less than 5. So is this less than 5? No. 0. Zero minus 0 is 0. Is 0 less than 5? Yes. And 10? 10 squared minus 4 times 10? 100 minus 40 is 60. 60 less than 5? No. So what's our solution? Yeah, in between -1 and 5. And I just have one question left, so we'll finish this chapter. We'll start chapter 2. Okay, so last one for this section. So there's an easy way to do this question and a hard way. What's the answer to this? Well, I want an absolute value, which is a distance, to be greater than 0. Okay, let's change it. Make it easier first. So if we had this question. So you might notice that anything that you plug into an absolute value gives you a positive answer. So everything would work, right? So you might just notice this and say, okay, well, this is all real numbers. That's just it. What if you didn't? What if you tried to write it out? So we say, okay, well, this is greater than, but it's just greater than 0. You really can't sort of follow the other path, like, because you can't say it's like bigger. Well, you can say it's bigger than 0 or less than 0, right? But that's just everything. So what if I change it this way? Close. So he said, is that x is all real numbers except 0. Right. So we don't want the ones that equal 0, right? Every other number will work, but anything that equals 0 won't work. So, right. So where does this equal 0? We don't want those numbers, because there's no equal 0 here. So we just want greater. Everything else will work. So if we factor this, we get 0 and -4. Now just quickly, without messing up, if I put those two numbers, that's where it's equal to 0. What's going to happen if I test points in these areas? This is going to work, this is going to work, and this is going to work. They're all going to work, because any number you plug in, and you can try it, we just don't have time, like physically plug that in, you'll get 100 minus 40 is 60, that's bigger than 0. You'll get 1 minus 4 is -3, absolute value -3, 3, that's bigger than 0. 1 plus 4 is 5, 5 is bigger than 0, right? Any absolute value, doesn't matter what ends up in here, you make it positive, so they all work. So you'd say all real numbers except x cannot be -4 or 0. So that's what you would say. So sometimes you'll plug them in and you'll get all works. What if you plug the test points in and you get nothing works? Then you conclude no solution. But it's not no solution if you don't get numbers. It's just no solution if nothing works when you plug it in. Well, you just contest any point, because there's no regions. So, yeah, either it all works or it all doesn't work. Yeah.